I'm Anil Kumar sharing with you a solution of a question posted by my subscriber Shruti, and I hope it is going to help many other students. The question here is, a mechanical digger is being used to dig a ditch for laying pipes under a road. The arm of the digger is articulated at A, and the two sections of the arm have lengths 3.8 meters and 2.7 meters as shown. If the operator keeps the first section fixed at 43 degrees, that's the first section, to the horizontal, and moves the second section to scoop out earth, what length of ditch will be worked in one swing of the second section to the nearest tenth of meter, right? So that is the digger, and if you scoop kind of like this, think like this. So that is how you scoop the mud, and these two sides being equal, we really are interested in finding the length DC. That is the basic question. So I hope now it's very clear what to find. You can always pause the video, solve the question, and then look into my suggestions. Now from here, we can actually find angle C using sine law, right? So we can say sine of angle C over opposite side is 3.8 is equal to sine of 43 degrees opposite 2.7. So sine C is 3.8 times sine of 43 degrees divided by 2.7. So let's calculate this. So we have 3.8 times sine 43 equals to, divided by 2.7 equals to, okay, a huge number, right? So we can write this number, let me write 4 digits, 9598. So angle C is basically sine inverse of this number, which is 0.9598. So we can do shift sine inverse of our answer, and that gives you 73.7 degrees. Okay, so that is to one decimal place. We got this angle C as 73.7 degrees. Now ADC is an isosceles triangle, so this angle is also 73.7, correct? Since it is an isosceles triangle, so this is also equal to angle ADC. Perfect. With that, we can actually find angle DAC, right? So now let's try to solve the triangle ADC. Now in this triangle, angle DAC should be equals to 180 degrees minus 2 times 73.4, right? Which is how much? So we have 180 take away 2 times 73.7. I think it's 73.7, not 4. So that is equal to, in decimals, 32.6. So this angle here is 32.6, correct? Now, with that and the side known, we can again apply the sine law. We can find what DC is. So DC over sine of 32.6 is equal to 2.7 over sine of the angle 73.7. So DC, the earth removed, will be 2.7 times sine of 32.6 divided by sine of 73.7 degrees, right? All these are in degrees. Okay, let's calculate this. So we have 2.7 times sine of 32.6 divided by sine of 73.7. and that gives us 1.5156. We want to round this answer to the nearest tenth of a meter, so this could be written as 1.5 meters, right? So 1.5 meters is what you get in one swing, right? So this distance DC is our answer. So that is how you could actually solve these questions, right? You can also appreciate that it's kind of a circle right there, and that becomes a chord of a circle. So the questions which are related to finding the chord length are also very similar in approach. So you can also have a look at those kinds of questions to practice sine law, and of course this is similar to ambiguous cases also. So these are all related questions which should help you prepare for this chapter. I hope you find it useful. Thanks for the question, Shruti. Keep sharing my videos. Thank you and all the best.